Aviation has come a long way since the Wright brothers took their first flight in the early 20th century.
This film, made in 1903, recalls the first flight of this primitive biplane making aviation history.
Airplane designs was pretty basic back then, and the glider-like plane could only carry a person or two. But modern-day airplanes are gargantuan beasts, capable of carrying hundreds of people at super fast speeds. Yet, the present-day airline industry is also bad for the environment, accounting for roughly 3% of global warming footprint. Considering the flourishing airline and tourism industry around the world, this number is projected to rise even higher. The carbon footprint of air travel is bound to grow to dangerous levels. Due to the efforts in creating awareness, even the multi-billion-dollar airline industry is also feeling pressure to reduce CO2 emissions to mitigate climate change. Bowing down to this pressure, they have begun to take some remedial steps. For example, older planes reaching retirement are replaced with ones that are more fuel efficient. Artificial intelligence-based algorithms are used to ensure that flights are scheduled with minimum vacant seats. Even so, is that enough? What more can be done? Should airplanes be redesigned, or could air traffic operations become more efficient and streamlined in some way? One of the leading ideas is to seek renewable energy sources to power aircraft. And in an ideological sense, a solar aircraft sounds like the perfect solution. How viable is the solar plane dream? Well, let's find out. Hey guys, this is Ronit Joshua and I hope you are doing well. In this video, we will learn about solar planes, their construction, advantages and progress. Andre Borschberg and Bertrand Piccard are two Swiss visionaries on a mission to bring a solar plane into reality. The Solar Impulse project was founded in 2003. The duo wanted to showcase the potential of a clean technology and demonstrate how they could be used to make the world a better place. Solar Impulse was their first experimental solar-powered aircraft project intended for a long-range flight. They roped in the Swiss government and the other corporations to finance their ambitious project. The Solar Impulse is a revolutionary airplane powered entirely by the sun's energy. Its mission is to promote clean technologies and inspire people to think about the environment and sustainability. In 2010, Solar Impulse took to the sky for the first time. Although this wasn't the first attempt to make a solar power plane, the project managed to achieve an unprecedented feat, a 26-hour flight solely using solar power. This included 9 hours of flying in the dark without any sunlight. The Swiss duo didn't stop here. They toiled hard with a team of engineers and other professionals to improve the design and working of solar aircraft. Solar Impulse 2 was a sequel to the original Solar Impulse project and was destined to reach even greater heights. In 2015, when Solar Impulse 2 soared through the air with wingspan wider than a Boeing 747, it became the first solar airplane to complete an oceanic crossing, flying from Japan to Hawaii using nothing but solar power. In the wee hours of July 26, 2016, Solar Impulse 2 landed in Abu Dhabi to eager crowds and cameras. After 14 months of travel and 550 hours in the air, the plane had accomplished what many had deemed impossible, traveling 40,233 kilometers around the world, over 4 continents, 2 oceans and 3 seas, without a drop of liquid fuel. The sun's fiber rays supplied in the craft's only power. Now let us talk about its advantages. Number 1. Clean and renewable energy source. Solar Impulse relies on clean and renewable energy from the sun to power its flight, reducing the dependence on fossil fuel and contributing to a cleaner environment. Number 2. Quiet and low emission flight. Unlike traditional aircraft, Solar Impulse produces no noise or emission, making it a much more sustainable and environmentally friendly option for aviation. Number 3. Cost effective. Solar Impulse reliance on the sun's energy makes it more cost effective compared to traditional aircraft that use fossil fuels, especially over the long term. Now, about the construction of the Solar Impulse 2 aircraft. Just like the domestic solar roof panels, the Solar Impulse 2 aircraft uses devices called photovoltaic cells or solar cells to generate electricity from sunlight. These cells are made of silicon and are very thin. Silicon is a semiconductor that conducts electricity in certain conditions while acting as an insulator in certain other conditions. Now when photons of sunlight hit a solar cell, it compels the electrons to move from one side of the silicon to the other. This flow of electrons is what we popularly call electricity. Solar Impulse 2 has 17,000 plus solar cells installed on its surface. The electricity this produces powers the aircraft's motors, which turn the propellers and charge the onboard batteries. These batteries preserve the power required by the aircraft to fly at night. The aircraft uses 630 kilograms of lithium polymer batteries, which account for roughly 25% of the aircraft's weight. In terms of motors, this aircraft has 4 electric motors, each delivering 17.5 horsepower. The Solar Impulse 2 aircraft uses clever composites, such as carbon fiber, in the plane's airframe to ensure that it is lightweight. Making the plane lighter means that less energy is required to keep the aircraft flying. During the flight, a solar plane switches automatically between the battery and the solar power. When they sun, it runs the propellers and charges the batteries on fuel cells. To charge the battery faster, the pilot can fly slower. At night or in clouds, the propellers run on the battery or fuel cells alone. When it's time to land, cut the power to stop the propellers. Solar planes glide down. Engineers would rather make them efficient flyers and fast at landing. They descend extremely slowly, says Dale Freight. When you're trying to bring one in for a landing, you'd like to grab it and pull it down. Despite the breakthroughs made by solar-powered airplanes, there are still changes that need to overcome before they can operate for commercial use. So let's talk about the progress of solar-powered aircraft. Number 1. Carrying capacity. The first challenge is the ability to carry hundreds of people. Keeping the airplane's weight to a minimum is the basic design philosophy of a solar-powered aircraft. Carrying more people means more weight, meaning that it is infeasible for solar-powered airplanes to take off with that much load, as the present solar-powered design and technology are not equipped for that. Number 2. Speed. The second issue with solar-powered planes is their appallingly slow speed. Whereas commercial-grade aircraft can cruise at a speed of 1,000 km per hour, solar aircraft struggle by around 100 km per hour. This implies that an 8-hour flight from London to New York would take more than 3 days to complete in a solar-powered aircraft. Number 3. Climate susceptibility. The third major challenge is that solar planes are extremely climatic. The best time for them to take off is understandably during the day. To efficient, although the weather is an important factor in the entire aviation industry, solar planes are extremely sensitive in this regard. Given their lightweight and slow speed, it can be nearly impossible to control the aircraft in heavy winds or during particularly harsh weather. Number 4. Skill requirement. The fourth challenge relates to the pilot. The skills required for flying a solar aircraft is much more extensive than the talent required to fly a normal plane. The pilot would first need to take off extremely carefully. Then, once the plane reaches at an altitude of 8,000 or 10,000 meters, the pilot will need to tactfully dodge dense cloud cover so that the sunlight was not blocked. In the conclusion, most aviation companies find solar-powered planes to presently be a risky proposition. Using a radically different airplane design would cost them billions of dollars, and if it goes wrong, those companies will be ruthlessly put out of business. Thus, solar planes for now still need a lot of improvement in terms of carrying capacity, speed, and safety when navigating seasonal variations. That's all for today. Thank you for watching, and if this study helped you, please do subscribe. See you in the next video.